Welcome to this tutorial where I'm going to show you how to calculate the t-value of an independent samples t-test and check for its significance. Now, in this example, our variable of interest is customer satisfaction. The grouping variable is gender. So we have female and male. So we want to know if there are any significant differences in terms of customer satisfaction between the two genders. Maybe one gender is a more critical customer than the other, but we would just want to look at the empirical results. What you will do first is to calculate some descriptives for each of those two groups. So we would calculate the means for each group. You calculate the mean by adding up all the customer satisfaction values and then dividing it by the number of cases. Then n is the sample size, so we have 25 cases in each sample, and then you have the variance of each sample of those two. So the variance would be simply the value minus the mean, and you square this term, and you add, you do this for all the values, and then you add them up and you divide it by the sample size minus 1, because it's the variance of the sample. If you have done that, you should check if the variances are equal in those two groups, in those two samples, or if they're unequal. Let's assume that you have equal variances. Then you apply the formulas you can see here. The first thing you would calculate is the pooled standard deviation. This formula just includes what we already calculated. So you have here sample size 1, and S squared is the variance, and this is sample 2, variance of sample 2, and so on and so forth. And then you would use this to calculate the denominator, and here in the numerator you simply have the difference in means between the two samples, so mean 1 minus mean 2. And this will give you the t-value. Now, what is the denominator actually? Well, this is the standard error of the sampling distribution of the difference. So it's a kind of norming the difference. This ensures that the difference you detect between the means is not just by chance, but this standard error puts it into a perspective and norms it so that you can be sure that the result is not just by chance. So when you have done that, you already have the t-value. As you can see here, this is minus 4, and then you only need the degrees of freedom. Degrees of freedom are just that you add up the sample sizes of both groups minus 2, because you estimated two means. You could now look up the critical t-value in a t-distribution table. So we have 48 degrees of freedom here, so you would go there, and actually beforehand you would have set an alpha value. This is typically 0.05, and this would be then significant because our value, or absolute value of 4, exceeds the critical t-value here of alpha 0.05. So this test would be significant. But also if we would have set an alpha value of 0.01, the critical value would be 2.68. Still, it would be exceeded by our calculated t-value. So we have a highly significant result here. Well, what else you could do is to let Excel calculate the exact p-value. And as you can see, this is also highly significant. Difference is only in a table, you will only get certain values. You might not even get 48. When the sample size gets a bit bigger, sometimes there's a jump from 40 to 50. So you won't get the exact p-value, but just if it's significant or not for your set alpha level. But you can simply calculate the p-value in Excel, and any standard software package gives you the p-value. Now, if your variances are unequal, you have to apply different formulas. The t-value here is again the difference between the means, and here again variance of sample 1 and sample size of sample 1. And well, the same for sample 2. And this will give you the t value. As you can see here, the degrees of freedom are a bit more cumbersome to calculate, but you just have to plug in the formula and go through the mechanics. As you can see here, the t-value does not differ much in this case, but there might be a more substantial difference between equal and unequal variance. So you should definitely check this and then apply the correct formula. Here you can see that the degrees of freedom are different, and this also shows a little bit in the p-value. So the steps would be the same. You could look it up, the t-value in the table, or let Excel calculate it like here. So just make sure that you check the variances, the equality of variances before, so you know which formula to apply. I hope this was helpful to you and that you now have a better understanding of how the independent samples t-test works. Good luck in your statistical endeavors.